We're going to be doing Cambridge Igcse Chemistry, Paper 2 Multiple Choice Extended, October-November 2025, Paper 22. The first question states, what happens to the volume of a fixed mass of a gas when the temperature is increased or the pressure is decreased? So the first thing we got to be careful about is the temperature should be increased. So if we have a fixed volume of gas and these are the particles and we somehow heat it from below, so what's going to happen is that the temperature of the particles is going to increase. So what's going to happen to particles? Whenever the temperature increases, the kinetic energy of the particles increases. And when the kinetic energy increases, because the temperature is increasing, what happens? The speed of the particle increases. So the particles are going to move faster. And when particles are going to move faster, what's going to happen? What's going to happen to the volume? Particles over here, they're going to hit with more force to the walls. And basically, when they're going to hit with more force to the walls, what's going to happen? They're gonna increase the pressure. When the pressure increases, to bring it back to normal, the volume has to increase, right? So when you increase the temperature, the volume also has to increase if the pressure remains constant, right? So volume has to increase. Decreased pressure. So for instance, you have a piston right here, and you have some random particles. Now you want to decrease the pressure. Decreasing pressure means that you move the piston upwards, right? You got to be careful. Decreasing pressure does not mean you move the piston downwards. It means that you have to move the piston upwards. If you're going to move the piston upwards and you decrease the pressure, you can see it for yourself. Initially, the volume was only this part, but after decreasing the pressure, moving the piston upwards, the volume increased to this much part, right? So if you decrease the pressure, your volume increases, right? So, which makes option D the correct answer. I hope you got the explanations. Okay, the diagram shows the heating curve for a substance. Okay, that's a substance is being heating. I assume over here it's a solid. Then on this line it's being converted from a solid to a liquid. Then it again gets heated. Then on this line it goes from a liquid to a gas, and then the gas continues to get heated, right? Between which 2 points do the particles of the substance change from being in fixed positions to being mobile, right? Change from being in fixed positions to being mobile, right? If I see on the first part of the graph, it's a solid, so it's in a fixed position, right? The next part of the graph, Q to R, it's basically melting, right? It's melting over here. A solid is being converted to a liquid. So over here, from Q to R, the particles are being changed from being in fixed positions, which they were from P to Q because it's a solid, to being mobile, are being changed, right? Substance changes. So it's going to be option number B, which is from Q to R, because over here, melting is happening. And what happens in melting? In solid, particles are fixed together. But when you melt them, the particles get a little space that they can move. So it's going to be from Q to R. A student investigates the diffusion of ammonia gas, NH3, and hydrogen chloride gas, right? Okay, ammonia gas and hydrogen chloride gas, they're being diffused. Two sets of apparatus are set to shown at room temperature and pressure. Apparatus 1 and apparatus 2. We have a source of ammonia gas. We have a damp red litmus paper. We know what ammonia is a basic gas. And what do bases do with damp red litmus paper? They turn them blue. So this has to turn to blue when ammonia is going to diffuse from here. And this HCl gas. HCl gas, is a acidic gas. And what do acids do to blue litmus paper? They turn them red. So this blue litmus paper has to turn red. The damp red litmus paper in apparatus 1 changes color after 30 seconds. Yeah, it's got to change color and it's got to turn blue. How long does it take for the damp blue litmus paper in apparatus 2 to change color? Okay, you know that the rate of diffusion from here to here of a gas depends on the MR, molecular mass of the gas. Ammonia gas basically is NH3. So the molecular mass of ammonia is going to be 14 plus 3, that is 17, right? 17 is the MR of ammonia. For HCl gas, chlorine is 35.5 and hydrogen is 1, which makes it 36.5. Hydrogen chloride gas is heavier than ammonia gas, right? Hydrogen chloride gas is heavier. And if a gas is heavier, what do you mean by it? What does it mean? It means it's going to diffuse more slowly or less slowly. it's going to diffuse less slowly. The heavier the gas, the more weight, mass, whatever the gas has, that's how slowly it's going to diffuse. So it means that for hydrogen chloride gas to reach from here to here, it's going to take more time, right? So for ammonia, if it took 30 seconds, for hydrogen chloride gas, it's probably going to take more than 30. Not 21, not 30, 64 seconds. Yeah, that's the right answer. The damn blue litmus paper does not change color. Why wouldn't it change? Hydrogen chloride is an acidic gas. And you know that whenever you have acids reacting with blue litmus paper, they're going to change it to red. Which row describes elements, compounds, and mixtures? Elements. You know, lithium is an element, sodium is an element. Why are they elements? Because they have all the atoms that are of the same type. All atoms of the same type. Yeah, that's correct. Compounds contain different atoms chemically joined together. That's a very important statement in compounds, that different atoms are chemically joined together. For example, if you have H2O and you have hydrogen and oxygen gas, okay, over here you have a container of H2O and over here you have a container of hydrogen and oxygen gas. You got to realize one thing. H2O, in H2O, it's a compound. Why? Because the molecules of oxygen, a molecule of water which contains oxygen and hydrogen, in this, the oxygen is chemically combined with hydrogen. There's a covalent bond between oxygen and hydrogen right here. So this is how things chemically combine. That's why water is a compound. But hydrogen and oxygen gas, if mixed together, they're a mixture. They're not a compound because there's no chemical bond between hydrogen and oxygen, okay? You got to realize these things. This one is correct. Can be separated into new substances using chemical processes. Can be separated into new substances using chemical processes? Yeah, that's correct. You can use chemical processes like electrolysis, like thermal decomposition, and you can separate them. Can be separated using physical processes. That's correct. Mixtures can easily be separated using physical process. For example, if you have a salt solution and you got to separate out the salt and water, what are you going to do? You're going to do a physical process that's called evaporation boiling. Contain different atoms chemically joined together. In mixtures, there's no chemical bonding involved. So option A has got to be correct. Which statement about atoms or ions are correct? You know, atoms are a fixed number of electrons and protons, but in ions, the electron number can change, right? The mass number of an atom is the total number of nucleons and protons. No, it's the total number of nucleons only. Why? Nucleons is basically, this is your atom and that's the nucleus. Now, with black, I'm going to be showing the protons, okay? It has 1, 2, 3, 4, 5, 6 protons, right? We can assume it's a carbon atom. And with red, I'm going to be showing the neutrons. It has three neutrons just for... Let me draw. If I say it's carbon, then it's got to be 6 or 7 or 8. 1, 2, 3, 4, 5, 6. It's a carbon-12 atom, right? All the protons and the neutrons together are called nucleons, or the protons and neutrons together called the nucleons. So the mass number of the nucleon number is same because you're telling the number of protons and the neutrons, right? So only the number of nucleons is the mass number. The electronic configuration of an aluminum ion is Al3 plus 2A3. That's incorrect. Why that is incorrect? Because for aluminum 3 plus ion, for aluminum atom, it's 283, right? 283. That means a total of 13 electrons, right? That's for a aluminum atom. A 3 plus means that it has lost that 3 electrons on the last shell, so it's got to be 28 for a aluminum ion. Hydrogen is the only atom that has an incomplete first shell. That's correct. Why is that correct? Because look, this is hydrogen and it only has 1 electron right here. And this is helium. These are the only 2 atoms that have 1 shell only. And helium has 2 electrons. So helium has a full first shell. It is 2 electrons. But hydrogen is the only atom in the periodic table which has an incomplete first shell. So it's got to be option C. Okay, option D says most of the volume of an atom is taken up by its nucleus. Oh my god. The nucleus is so small that it takes the least, like, if you can imagine an entire football stadium to be an atom, the nucleus is just going to be a pea or a blueberry in it. That's how small the nucleus is. And it's densely concentrated with mass and positive charge. Which 2 values are used to calculate the relative atomic mass of a sample of boron? What do you take when you're calculating the relative atomic mass? I think that's simple. We just take their mass numbers, okay? We take their mass numbers and we take their relative abundances. And the masses, right? The total number of boron, the number of isotopes never mattered. I guess if you know that formula, mass into abundance of the first plus mass into abundance of the second divided by the total abundance, you just need the mass and the abundance. The relative abundance of each boron isotope in the sample. The relative abundance, yeah, abundance is important. The relative mass of each boron isotope. Yeah, that's correct. You gotta have the abundance, you gotta have the mass, and you're gonna calculate out the relative atomic mass. The total number of boron atoms and the abundance. That's the same thing, kind of the same thing if you have the not needed. The total number of boron isotopes, no, B. Which statement describes the structure of sodium chloride? Sodium ions, chloride ions, a lattice of alternating positive and negative ions, 100% correct. And this is an exact statement which is written in the syllabus, right? Exactly from the syllabus. I remember I read the syllabus in ionic compounds. The first statement that they have told in the syllabus in ionic compounds is a lattice of, describe an ionic compound as a lattice of alternating positive and negative ions. A lattice of positive ions surrounded by a sea of delocalized electrons. That's metallic bonding. A mixture of sodium chlorine atoms, no, that's an ionic compound, so you're going to have ions. A regular lattice of sodium and chlorine atoms, no, you're not dealing with atoms, you're dealing with ions over here. Graphite and diamond are both forms of element carbon, which shows the number of other carbon atoms that each carbon atom is covalently bonded in graphite and diamond. In graphite, you have hexagonal rings, something like this. I've not drawn them properly, but yeah, you have hexagonal rings. And in a hexagonal rings, each carbon atom is covalently bonded to 3 other carbon atoms. Now this makes sense. It's something like this. That is how the structure of your graphite looks like. So you can calculate each carbon atom is always going to be bonded to 3 other carbon atoms. It's going to be making 3 covalent bonds. Each carbon atom is bonded to 3 other carbon atoms, right? So in graphite, each carbon atom bonded to 3 other carbon atoms. And in diamond, I don't think there needs to be any misconception about it. In diamond, each carbon atom is covalently bonded to 4 other atoms, right? So in diamond, there are no delocalized electron because all the outer electrons of carbon are involved in covalent bonding. But in graphite, there's a 4th delocalized electron because you know that carbon has how many electrons in its last shell? 4. 1, 2, 3, 4. And 3 of them are involved in forming bonds. So this last delocalized electron can move through the structure of graphite to conduct electricity. Which would describe the structure and bonding in cobalt. Structure and bonding in cobalt is going to be, because it's a metal, right? And you know metals have giant structure, so it's going to be giant. And bonding is going to be metallic because it's a metal, right? The equation for the combustion of ethanol is shown. The relative molecular mass, MR of ethanol is 46. MR of ethanol is 46. Okay. Which statement about the reaction is correct? 4.6 gram of ethanol produces 4.4 gram of carbon dioxide. Incorrect. Because look at the ratios. It's 1:2, right? Write it down over here. Ethanol is C2H5OH and carbon dioxide, it's 1:2. The mass of 1 mole of ethanol is 46 and the mass of 2 moles of carbon dioxide is going to be how many grams? 1 mole is 44, so 44 plus 44, that's got to be 88. It's 88 grams. So if 46 grams of ethanol gives you 88 grams of carbon dioxide, then 4.6 grams of ethanol is going to give you 8.8 grams of carbon dioxide. So definitely not going to go with option A. 92 grams of ethanol produces 88 grams of carbon dioxide. No. 88 grams of carbon dioxide is going to be produced by 46 grams of ethanol. 138 grams of ethanol reacts with 32 grams of oxygen, okay? Let's see. So over here, 1 mole of ethanol reacts with 3 moles of oxygen. That means that 46 grams of ethanol, which is the mass of 1 mole, is going to react with 3 times the mass of 1 mole of oxygen, which is 32, which is 90, not 90, yeah, it is 96 grams. So it's going to react with 96 grams, which makes automatically option D the correct answer. No, not even going to work. Okay. A compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen only. The relative molecular mass of the compound is 60. Which row shows the empirical formula and the molecular formula of the compound? Okay, we have to count it. Calculated carbon, hydrogen, oxygen. This is 40. This is 6.7. This is 53.3 divided by 12 divided by 1 divided by 16. Gonna go on my calculator. 40 divided by 12, and that gives me 3.33. 3.33, this is gonna come out to be 6.7, and 53.3 divided by 16. 53.3 divided by 16, 3.33. 3.33, and now we're going to divide all of them by the smallest number, which is 3.33. 3.33, 3.33, 1:2:1. CH2O. CH2O is the miracle formula. How do you calculate the molecular formula? You take the molecular formula mass, which is 60, divided by the empirical formula mass, which I think is going to come out to be 12 plus 16 plus 2. 12 plus 16 plus 2, that's 30. 60 divided by 30, going to give me a 2. Multiply this 2 by your empirical formula, right? So this is going to give me C2H4O2, which makes this option to be my correct answer. Hydrogen oxygen fuel cells are used in electric cars. Which statements about fuel cells are listed? Okay, the process in the cell is called electrolysis. Water is broken down in the cell to produce hydrogen, and water is the only chemical product formed in the reaction. The first thing you got to realize is that hydrogen oxygen fuel cells, they take hydrogen as fuel, combust it, and then they produce your water. So it's basically hydrogen, right, reacting with oxygen to produce 2 moles of water. There's a 2 here. So the third statement, which says that the only chemical product is water, seems correct because water is the only chemical product in the reaction. So this is correct. Water is broken down. Water is not broken down, it's formed. The process in the cell is called electrolysis. No, it's not electrolysis. Why it's not electrolysis? Because in electrolysis, what's happening is you break down a compound. Over here, a compound is being formed. Look, you have hydrogen, you have oxygen, you're forming water. What do you do in electrolysis? In electrolysis, you already have a compound like NaCl and you break it down into sodium and chlorine. That's what you do in electrolysis. The only correct statement is this one, which is option number 3. Okay. A solution of copper 2 sulfate can be electrolyzed using copper electrodes or carbon electrodes. Which statement is correct? Using copper electrodes, oxygen gas forms at the anode. When you use copper electrodes, always remember no gas is going to form. Why? Because when you use copper electrodes, copper oxidizes and copper is reduced. Statement number 2 says that using copper electrodes, copper atoms lose electrons at the anode. Okay, so you know that anode, what happens at anode? Oxidation is going to happen in anode. Okay, so at anode, what's going to happen? Oxidation is going to occur, and oxidation is basically your loss of electrons. So this statement that using copper electrodes, copper atoms lose electrons at the anode, this is correct. Because you should know that anode, oxidation. Using carbon electrodes, copper metal forms at the cathode. That's correct or not. For that, you got to know one thing. That's the reactivity series. In reactivity series, hydrogen is above copper, right? And if hydrogen is above copper, then you know that what just discharges? The ion or the metal that is less reactive discharges. So in the reactivity series, copper is below. So copper is going to get discharged, right? Not the hydrogen. It's going to be copper that's going to be discharged. So over here, we're going to tell them that when we use carbon electrodes, all the positive ions we have are hydrogen ion and copper 2 plus ions. Out of them, copper is more unreactive, so it's going to discharge, which makes option 2 correct. Next says, using carbon electrodes, copper ions gain electrons at the cathode. That's correct, because you know that at the cathode what's happening? Your reduction happens at the cathode. And what is reduction? Reduction is basically your gain of electrons. So at the cathode, that means you're gaining electrons. So using carbon electrons, copper ions gain electrons at the cathode. That's going to be correct, which makes option 2, 3 and 4 all 3 correct. If you don't understand this, just know that this is your anode, this is going to be your cathode, and what's going to happen is that when you are using your copper electrodes, right, this is copper and this one's copper, right? What's going to happen is that copper is going to get discharged from here. At the anode, copper is going to get oxidized and form copper 2 plus ions, and then at the cathode, the 2 plus ions are going to get reduced. That means they're going to gain electrons and form copper metal again on the cathode. That's simply oxidation and reduction of copper. Dissolving ammonium chloride in water is an endothermic change. So when we're dealing with endothermic changes, we know that energy is being released, right? We gotta know this, that we're releasing energy or absorbing. We're releasing energy as well. And we are absorbing energy as well. People think that in endothermic changes, you're only absorbing energy. That's wrong. You're doing both. You're releasing energy. When you form the bonds, you're absorbing energy when you break the bonds. But in endothermic change, the only difference is that you absorb more energy than you release. You release less energy, you absorb more energy, right? But it does not mean that you don't release any energy. You do, but the energy that you absorb is greater. Which row shows the energy change and the temperature change of the mixture during dissolving of ammonium chloride? Energy change. Okay, temperature change is going to be, you know, that since we're absorbing more energy, so the temperature is going to decrease. And you know that energy is going to be absorbed. It's going to be released as well, but more is going to be absorbed, right? More energy gets absorbed than released. Okay, aqueous sodium thiosulfate, Na2H2O3, reacts with dilute hydrochloric acid to form a yellow precipitate of sulfur. This is thiosulfate. It's reacting with HCl. It's forming NaCl, H2, sulfur, and SO2. Okay, the precipitate forms more quickly when the reactants are heated. Which statement explains this observation? Okay, so they're saying that we're performing a reaction and the reaction is quicker when the reactants are heated. Why? You should know that when we heat something, we increase its temperature. And when we increase its temperature, what we're increasing is the kinetic energy of particles. And when we increase the kinetic energy of particles, they collide more frequently. And more particles have energy equal to or greater than the activation energy. So the reacting particles collide more frequently, that's correct. The collisions between reacting particles have more energy, that's correct. The activation energy of sulfur is lower. No. The only factor that can change activation energy is a catalyst. So you got to write that a catalyst can only alter activation energy, right? Only a catalyst can alter your activation energy. Nothing apart from a catalyst can do it. Only a catalyst. which makes option 1 and 2 the correct answers. Right? If they would have said that we've added a catalyst, then we could say that the activation energy is lowered. But they're not adding a catalyst, they're just simply heating the mixture. Which statement about the conditions used in the Haber process and in the contact process is correct? The typical temperature used in the Haber process is similar to that used in the contact process. The typical temperature used in the Haber process is similar to that used in the contact process. Okay, first they're talking about the typical pressure, then they're talking about the typical temperature. The Haber process uses vanadium oxide and the contact uses iron. That they've reversed it. The pressures are not the same. Both processes produce an acidic gas. Okay, Haber process produces ammonia, right? Which is NH3, which is a strongly basic gas, right? Ammonia is a base, you should know. And your contact process produces which gas? It produces your sulfur trioxide gas, which is acidic. So this is also wrong. The typical operating temperatures for both is almost the same, which is around 450 degrees Celsius, 400 to 450 degrees Celsius, around in this temperature range, right? So that's the correct one. Okay. The equation shows the equilibrium between dinitrogen tetroxide N2O4 and nitrogen dioxide. The colors of the reactants and the products are shown. So this is colorless, this is brown. The forward reaction is endothermic. So important piece of information given to us is that the forward reaction is endothermic. So the backward reaction has got to be exothermic, right? Which statement is not correct? Not correct, okay? At equilibrium, the concentrations of the reactant and the product stay constant. That is exactly what equilibrium says. There are two statements about equilibrium, you got to remember. Statement number 1 about equilibrium is rates of forward and backward reaction are same. So rates for forward and backward reactions are same. And the second statement about equilibrium is this one, that the concentration of your reactants and products stays constant or unchanged. At equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. Correct. When the pressure is increased, the darker brown color is seen. Okay, so over here you have 1 mole and over here you have 2 mole, and you know when you increase the pressure, the equilibrium shift toward the side that has less moles. So if I increase the pressure, equilibrium is going to shift backward, right? So it's going to move towards 1 mole, and if it moves towards 1 mole, it's got to go more colorless, right? So when the pressure is increased, a darker brown color is seen. That's incorrect. So this is our answer because we had to choose the incorrect option. So turns more colorless, not darker brown. When the temperature is increased, a darker brown color is seen. Yeah, that's going to be correct because when you increase temperature, the equilibrium is going to try to decrease it, and to decrease it, it's going to do the endothermic reaction because endothermic reactions absorb heat energy. And when it's going to do the endothermic reaction, you're going to see a more brown color. Why a more brown color? Because you're going forward to do the endothermic reaction. So it's going to turn darker brown, right? What is the oxidation number of chromium in Cr2O72 negative ion? We have to figure out the oxidation number of chromium. What we're going to do? We know that Cr2O72 negative has a 2 negative charge, right? First, we're going to know that oxygen is going to be in -2. And we have 7 oxygen. So -2 times 7 equals to a -14, right? To balance out a -14 charge, we need a +14, right? But over here, we don't need to exactly balance out -14. We just need a number which is +12 and -14. That's going to give me a -2. I don't need to fully balance out my compound because this is not a stable compound. It has a charge on it. So I need a +12 on chromium, right? So these 2 chromiums have a charge of +12. Why? because this oxygen total has a negative 14 charge, because negative 14 and positive 12 is going to give me answer of negative 2, and I need an answer of negative 2. Now, since my 2 chromiums has a charge of positive 12, so 1 is going to have a charge of 12 divided by 2, which gives me a positive 6 charge for 1 chromium. So it's going to be a positive 6. I guess that's fairly easy. Which method is used to prepare a pure dry sample of lead chloride? First things first, you gotta figure out, is lead chloride soluble or insoluble? According to my rules of solubility, lead chloride is a soluble salt because all chlorides are soluble except silver and lead. Yeah, lead and silver. Yeah. Where is my solubility rules? So it's insoluble then. Good, I figured out. So this gotta be insoluble, right? Lead chloride. Calcium sulfate, lead sulfate are insoluble, and lead chlorides and silver chlorides are insoluble. So this is insoluble. And when we have insoluble, we prepare it by the method of precipitation. So we gotta do precipitation here. And in precipitation, we get a filtrate, a residue, we filter out, and that's how we do. And you should know, you gotta use 2 soluble salts, soluble plus soluble, to make a insoluble salt, okay? You use 2 soluble salts, 1 soluble, 2 soluble, to make a insoluble salt, right? So mix aqueous lead 2 nitrate and dilute HCl. Very good. This is soluble, this is soluble. Filter, crystallize. Why crystallize? We're forming a precipitate. We're not going to crystallize it. So cross. Okay, mix aqueous lead nitrate. Good. Dilute hydrochloric acid. Good. Filter. Yeah. Wash and dry the residue. That's correct because we're forming precipitates. Why do we have to filter? Option B is the correct answer. Phosphorus is an element in group 5 of the periodic table. It burns in air to form an oxide that dissolves in water to form a solution of pH 1. Okay, what they're trying to say is that your phosphorus, it's going to burn in oxygen to form an oxide, which is something like this. You don't need to remember the formula, just a random oxide. And this oxide is going to react with water to basically give you a solution which has a pH of 1, right? And pH 1 means we're forming a, you don't need to know these reactions, you just need to know when you have pH 1, that means you're forming a acidic solution. So which row describes oxide of phosphorus? It's a metal oxide? No, phosphorus is a non-metal. Non-metal oxide, yeah. Acidic oxide, yeah, it's gotta be acidic because it's forming a solution with water that has a pH of 1. Basic oxide, no. Simple. Option C. It's not a metal oxide, it's a non-metal oxide that's acidic. The equation shows the reaction between aqueous hydrogen bromide and aqueous ammonia. This is hydrogen bromide and that's ammonia, forming ammonium ion and a bromide ion. You know one thing, what's happening over here. This is a new concept, you gotta know this. A bromide ion, just look over here, what's happening. You're gonna get it. A bromide ion has a proton with it, right? An H plus ion is known as a proton in chemistry. So this bromide ion has a proton with it. And this bromide ion is donating its proton to this ammonia. Look, ammonia has a NH4 over here. Over here it was NH3. So this H plus from here got transferred to ammonia. So what's happening? This hydrogen bromide is donating its proton to ammonia. So it's a proton donor, right? And it's losing its proton. And you know that proton donors are acids. So HBr is an acid over here because it's donating its proton to this fella, right? Which statement describes the role of aqueous hydrogen bromide? It's a proton donor because it's donating this proton it has to this ammonia. That's why ammonia is a base. Because ammonia tends to be a proton acceptor, right? It tends to be a proton Acceptor. It's accepting a proton to form ammonium ion. Which statement about elements in group 1 is correct? Hydrogen is produced when group 1 elements react with water. That's 100% correct. Because if you have sodium and you make it react with water, what are you going to form? You're going to form NaOH plus H2, right? I guess that's simple, that's easy, that's what you've learned. Ions of group 1 have a 1 negative charge, no, a 1 positive charge. Sodium is more reactive than potassium, no. Down the group, your reactivity increases in group 1. So sodium is above, potassium is below. So potassium got to be more reactive. Solid, sodium is a poor electrical conductor. No, it's a metal. And you know that metals have a metallic lattice, and when they have a metallic lattice, they have a positive ions and a sea of delocalized electrons, and the sea of delocalized electrons can travel through the metallic lattice to conduct electricity. So that's all wrong. Which row describes the color and state of iodine at room temperature and pressure? You know iodine is a gray black solid, so B. You got to learn this. You got to learn chlorine, bromine, and iodine at room temperatures. This one right here is a yellowish greenish yellow gas. This is a red brown liquid, and this one right here is a gray black solid. That's stated in syllabus. What are the periodic tables shown which gas is inert? Obviously group 0 or group 8. They're inert gases. Why? Because they have a full outer electron shell. 4 different metals are separately added to water. The oxide of each metal is separately heated with carbon. The results are shown. Metal with water, no reaction, rapid fizzing, a few bubbles, metal oxide with carbon, a brown solid forms, okay, no reaction, a gray solid forms. What is the order of reactivity of the 4 metals? First, you got to realize the metal oxide that's going to react with both water and carbon is going to be the most reactive. So T over here is reacting with both, right? I guess only T is reacting with both. A few bubbles in a gray solid forms. But, no. There's one more thing you gotta realize. That look, metal oxide react with carbon. That means that carbon cannot displace that oxide, right? So R, no reaction is going to occur if you have an oxide of R, like RO, and you add carbon to it. So since RO is going to be more reactive, right, this carbon cannot displace this R, right? So R is going to be more reactive than carbon. So over here, the most reactive is going to be R. Least reactive is going to be Q, because over here, if you have an oxide of Q, which is QO plus carbon can easily displace QO and form whatever this brown solid is, right? Now we're just going to decide for T and S, okay? T and S, this thing. Look, S and T, right? SO and TO both react with carbon, and over here, gray solid forms. For TO, the oxide of T reacts with carbon to form a gray solid. That means carbon can displace it. That means T is less reactive. For S, carbon cannot displace the oxide of S, so there is no reaction. So T is more reactive, S is less reactive. No, I said it in a reverse way. T is less reactive, so it's got to be here. S is more reactive because in S it cannot displace, in T it can displace. So option A. It was a little confusing, but like we did it. No worries. An iron nail is fully covered with zinc to prevent it from rusting. Which row describes this method of protection and explains why zinc is used to protect the nail? Method of protection. It's both barrier and sacrificial. It's barrier because this is your iron nail and this is your zinc, right? This is your zinc. So now, first you're adding a barrier over it, right? This zinc is a barrier over this iron nail. This zinc is a barrier for this iron nail. And sacrificial protection because zinc is more reactive than Iron. So if any oxygen comes over here, zinc is going to react with it and not make iron react with it. So reason it's used, zinc is more reactive than iron. Yeah, zinc is more reactive than iron. So option A. Iron is extracted from hematite in blast furnace, which reaction increases the temperature in the blast furnace to over 15 degrees Celsius. This is a decomposition reaction. You have calcium carbonate, you're decomposing it to calcium oxide and carbon dioxide, so definitely not. This is not going to increase, this is going to decrease. Calcium oxide plus silicon oxide or IV oxide forming calcium silicate. This is an acid-based reaction, right? You have a basic oxide and acidic oxide reacting. Carbon plus oxygen forming carbon dioxide, and carbon dioxide plus carbon forming carbon monoxide. This reaction over here, this is a reduction reaction, right? Carbon dioxide is being reduced to carbon monoxide. And over here, carbon plus oxygen, this is a combustion reaction. So this reaction, which is combustion, is going to generate heat, because combustion reactions are exothermic. So this got to be exothermic. So it's going to generate heat. Aluminum is extracted by the electrolysis of purified bauxite, which row shows the half equations at the electrodes and explain why one of the electrodes has to be replaced regularly. Okay. So half equation at the anode. Anode is your positive electrode on which your negative ions come. So cross. Electrode replacement. Cathode replaced. No, we don't replace cathode. We replace anode because it reacts. The anode is basically your carbon, right? This is your carbon anode, and the oxygen that's formed reacts with your carbon anode to form carbon dioxide. So your anode basically gets used up, so you got to replace it regularly. Which flowchart describes the correct treatment sequence for the domestic water supply? Sedimentation, chlorination, filtration. Okay, chlorination, filtration, sedimentation. Filtration, chlorination, sedimentation. Okay. First of all, what do? You remove the heaviest particles. So it's going to be removed by sedimentation. Then you remove a little less heavier, which are going to be replaced by filtration. And then you remove microscopic particles that are going to be removed by chlorination. So that's the correct way. First, the heavier one, sedimentation, is going to remove all the very heavy solids. Then filtration, like that are going to be a little smaller. And then chlorination is going to remove your microbes, which you cannot see with your eyes. I mean, you can, but like with a microscope, right? Which statement about oxides of nitrogen is correct? They're made in car engines by the incomplete combustion of gasoline at high temperatures. No. In your car engines, basically, this is your car engine, right? The temperature gets very high. And at high temperatures, the nitrogen in the atmosphere can basically react with your oxygen to form your nitrogen oxides, right? They're made in car engines when nitrogen in gasoline reacts with oxygen, nitrogen in gasoline. In gasoline or nitrogen in the atmosphere? So I don't believe it. They're removed from car exhaust by catalytic converters and form nitrogen and sulfur dioxide. Why would you form sulfur dioxide? They're removed from car exhaust when they react with carbon monoxide in the catalytic converters. This is correct. Why is option B wrong? Because when nitrogen in gasoline, no, when nitrogen in the atmosphere reacts with your oxygen. Which alkenes are a homologous series? The alkenes are a homologous series. Which statement about the member of the homologous series is correct? They have the same functional group. Yeah, that's correct. The diagram represents two processes, X and Y, and their effect, Z, in increasing global warming. Okay, which row identifies X, Y, and Z? Emission of thermal energy from Earth. Okay, X absorption. Okay, so that's your Earth. And then you're emitting some thermal energy out of it. Emission of thermal energy from Earth. Absorption of thermal energy by greenhouse gases. Emission of thermal energy by greenhouse gases. Okay, they absorb, they emit. Absorption of thermal energy by greenhouse gases. Okay, emission of thermal energy, whatever. And then why? So first, they're gonna emission of thermal energy from Earth. Okay, emission of thermal energy to the Earth, right? Emission of thermal energy to the space, reduced thermal energy lost to space. Emission of thermal energy by greenhouse gas. Okay, greenhouse gas are gonna emit thermal energy. There's gonna be, they're not gonna emit, they're gonna absorb. Absorption of thermal energy by greenhouse gases. Emission of thermal energy to the Earth. Emission of thermal energy to the space. Not increased thermal energy lost to space. Let's just cut these two out. Absorption of thermal energy by greenhouse gases. Emission of thermal energy to the Earth. Reduced thermal energy lost to space. Option A. It was a little trickier, but I figured it out. How did I? Because I didn't even learn this thing, but this simple thing that if the thermal energy is going to be absorbed by greenhouse gases, they're going to emit thermal energy to the Earth, and then there's going to be reduced thermal energy lost to space. Why there's going to be reduced thermal energy lost to space? Because the energy is going to be absorbed by the greenhouse gases. Which structures are structural isomers of each other? This and all of 1, 2, and 4 are same. So look, this straight chain, this is a straight chain, this is a straight chain, only this chain has a branch. So 2 and 4 are both straight chains. 1 and 3 yeah, 1 and 3 are isomers. Why? Because this is a normal molecule and this is its branched form, and branches are isomers. These are straight chains. Only this is branched, because to complete this I need to reverse my pencil. The structure of an ester is shown. What is the name of the ester? Oh my god. Methyl propanoate. That's all I need. Which row shows the products obtained by the cracking of large alkane? You don't form water. You form hydrogen, you form alkenes, but no water. Ethanol is produced by the fermentation. Yeah, we know. And there is one more. There's electrophilic addition, or you can say catalytic addition of steam to ethene. Right? Which row shows some of the advantages and disadvantages? Advantage of fermentation. Fermentation is slow, not fast, bro. Ethanol produced in batches. Is this an advantage that you have batches? No. Fermentation, renewable raw material. Yeah, because for fermentation you use glucose, and glucose is renewable. Ethanol produced in batches. Yeah, that's a disadvantage. You gotta have batches. Catalytic addition, almost pure ethanol form. That's correct. The purity is very high for this reaction. Slow reaction. Dilute aqueous ethanol formed. Disadvantage is that it's a slow reaction. No, this one is not a slow reaction. It's a fast reaction. Right? So, incorrect. Option D, renewable raw material, correct. Dilute aqueous ethanol formed. Maybe that's a disadvantage. Fast reaction, yeah, this one's a fast reaction. Non-renewable raw material, yeah, that's correct, because the raw material that you use is ethene, and ethene comes from your crude oil, right? And crude oil is non-renewable because you get it from earth, because it's a fossil fuel, so it's non-renewable. Okay, propanoic acid is an organic compound that is both an alkene and a carboxylic acid. It's an alkene because it has an alkene functional group. It is a carboxylic acid because it has a carboxylic acid functional group. Which structure represents one repeat unit of the addition polymer of propanoic acid? For that, what do we got to do? We got to arrange everything above and below it. So this entire thing is going to come below it because we need carbon double bonded carbon in the center. Above H, above H, below COOH. That's one repeat unit. You extend the bonds, you remove the double bond, and that's your repeat unit. So where is this thing written? Here. Done? Which item of apparatus is used to measure 13.7 cm cube of dilute hydrochloric acid? A burette. A pipette cannot measure this much a fixed amount. Why? Because a pipette can measure 25.00 cm cube or 50. Pipette comes in fixed amount. A conical flask is used for titration. A balance is used to measure mass, not volume. Chromatography is used to separate and analyze mixtures of soluble substances. The first step in the process is listed. Apply sample to the baseline. Develop chromatogram in solvent. What is the next step in the process to detect soluble colorless substances? If it's colorless, then you got to have a locating agent, right? A locating agent is basically used for your colorless substances. So that's all. Bye-bye.